Okay, so I wanted to do one more example in Module 8, and then for the final example you can also look at the completed notes that are online. It says a consumer group suspects that the proportion of households that have 3 cell phones is 30%. A cell phone company has reason to believe that the proportion of households with cell phones is not 30%. Before they start a big advertising campaign, they conduct a hypothesis test. Their marketing people survey 150 households with the result that 43 of the households have 3 cell phones. Okay, so notice first here that we're talking about proportion, not means. So we want to notice that. We know that because in this case it does say proportion, or if we're given a probability, or sorry, a percentage, like the 30%, or if it, in this last part here where it says we survey a certain number of people and so a certain number of them have 3 cell phones. So any of those things tell us it's a proportion. They're not talking about an average number of people or an average number of cell phones. They're talking about this many people out of the 150 surveyed. So the consumer group suspects this. So this is going to be our population proportion, our assumed population proportion, and then this is our sample data here. Okay. So one thing we can do is this kind of asks us to do a few things before we even get to the null and alternative hypothesis. But P prime, which also could be called P hat, is that, is the sample data. Okay, so this is going to be 43 out of 150. 43 out of 150 say that they have 3 cell phones in their household. So that is going to be our proportion from our sample data. Okay, now depending on what kind of technology we use, the technology may ask us for those raw values for the 43 and the 150. If that's the case, this is what we call X and this is what we call N. So X is the number of yeses or successes and N is the sample size. Or they may ask us for that percentage, or you may just see it in the technology. Okay, so it's about 28.7% is what we're getting as the sample. So a success for this problem, we could say it's a household that has 3 cell phones. That's the yeses, that's that X. What's the level of significance? That's our alpha. If it doesn't say, which if you go back and read this, it doesn't say, then we're going to assume that alpha is 0.05 or 5%. Okay, so this is assumed because it is not given. Okay. Write out the null hypothesis and the alternative. So our null hypothesis is that the proportion, the population proportion, is 30% or 0.30. So in here it says a cell phone company has reason to believe that the proportion is not 30%. It doesn't say from the beginning, before we look at the sample data, it doesn't say whether it thinks it's bigger or smaller. They just think that that is wrong. Maybe they just said, you know, you didn't have a good sample, that, or the proportion, whatever it is wrong, right? We think that things have changed in time, and so they feel that it's not 30%. So now, once we have this, we can go ahead and do our test, because the next thing it wants is the p-value, which we get from our hypothesis test. So just thinking about those 3 questions that sometimes we ask: how many samples, 1 or 2 samples, means or proportions, and if we're going to use a z-test or a t-test. So in this case, we only have 1 sample. We are talking about proportions. Proportions, we always use a z-test, so we don't have to decide there. So if we're doing it on the calculator, we would say that, let's see, we go into stat, we go to tests, and we want a 1 proportion z-test. Okay, so that these 4 are sample tests, and then we have proportion tests. So a 1 proportion z-test, This is my population proportion, so that's going to be my 30%, my 0.30. This is where it's asking for the x and the n, so 43 and 150, and then my alternative hypothesis is just that it's not equal to. So we're going to calculate that. Now you notice here's my p hat that we had calculated before, here's my z-score or my test statistic, and here's my p-value. Okay, so my p-value here, there's a p-value, to not get confused with proportion. So p here is the p-value, p hat is my sample proportion. My p-value is 0.7216. If you do it on art of stat, you may just have 3 decimal places given to you for the p-value, and that's okay. If you're on art of stat, you're going to go to inference for a proportion, and that is where and do a significance test. So my decision, well, in order to do my decision, I have to compare my p-value with alpha. So my p-value is 0.7216 or 0.722, and my alpha is 0.05. So my p-value is much greater than my alpha. This tells me that I fail to reject the null hypothesis because, so that's my decision, my y is because my p-value is greater than alpha. What's my conclusion? At the 5% significance level, we fail to reject the null hypothesis. There is not enough evidence to conclude that the population proportion is different than 30%, or you could say is different from 30%, or not enough evidence to conclude that the population proportion is not 30%, whatever you want to call that. Okay, all right, so there's one last example in these notes. I'm going to not do it on here just for time. I know you've looked at this long enough between these two. So you can kind of see the same idea though, go through it, look at it on the completed notes. You can see right away they're talking about mean length, and so you have your alpha in there. You can think about what you have and how you would do that. All right, and there will be more videos posted as well. Thanks guys.